is called McMillan's theorem. So let L of x be code word lengths for any uniquely decodable code. Then sum over x, cardinality of u, the minus L of x, less than or equal to 1. And this is Kraft inequality, the Kraft inequality. This is what we said was the Kraft inequality. So far today we've been dealing with the case of base 2 for binary. I'm going to continue dealing with that. Just understand that nothing really changes if we substitute out the 2 and put back in cardinality of u. Okay, proof. What's the uniquely decodable code definition? If a code is uniquely decodable if its extension is non-singular. So remember what the extension of a code was. The extension of a code was, for instance, if I have, remember my simple example from last time, A goes to 0, B goes to 1, 0, C goes to 1, 1. The extension of this code was all collections of basically substituting in all sequences where, for instance, if I had A, B, C, B, A or something, then I would just substitute in the code word for each of these. And this is the extended code word. So the extension is basically mapping vectors of source letters to vectors of code bits. A non-singular code is one for which all, for any unique input, the output is unique. So the reason why it's uniquely decodable is because we deal with code extensions. If the extension is non-singular, then every input vector of source symbols leads to a unique output vector. Output vector of channel symbols. Okay, so to start dealing with this, let's look at taking the Kraft inequality expression and we'll raise it to the kth power. So this will lead to something like the extension of the kth extension of the code group. So this is equal to, I can break this up into terms like this. Where each one gets its own dummy variable in x. So each of these terms in this product would be the the same value. So basically, what have I done? I've basically done this. I've said, I've taken this and I've broken it into this. K times.
Why did you need K?
Eventually we'll let K go to infinity. But what I'm going to end up with is an expression that gives the Kraft inequality over the kth extension of the code. So this is a somewhat arbitrary place to start, but it will become clear why we're doing this a few lines down. So basically what I've done is this. I have K copies of this, and it doesn't make any difference if I call these variables of summation different things. So that's what I've done here. I've just made these variables of summation into different dummy variables for each copy. So what's going on in this product is that each term in the product is only in xi. So what I can do is I can take the sums out. I can take the sums out of the product. And then I am left with product from I equals 1 to k of 2 to the minus L xi. And what I can do then is I can collect the terms in the exponent. So because I'm multiplying from 1 to k of 2 to the minus Lxi, I basically take the sum in the exponent over here. So that's 2 to the minus sum from I equals 1 to k of Lxi. We can rephrase this. What is this? This is the sum over all possible values of a length k vector in X. I'm basically taking the sum over all x1, x2, and so on up to xk. So if I call this the sum over all vectors of length k, I can also call this, what is this? This is the sum from I equals 1 to k of Lxi. So if you think about that, given x1, x2, x3, x4, x5, if I take the extension of the code, then x1 maps into a code word with Lx1 length, x2 mapped into a code word with Lx2 length, and so on. This is actually the length. If I take this vector of k source letters, this is the length of the extension, the kth extension of the code word, because I'm adding the length of the first code word to the length of the second code word to the length of the third code word. So if I map this to its code word expansion, the length of that would be this, the sum from I equals 1 to k of all the k code words. So I'll write that like this. Sum over all vectors, x, all k-fold vectors of x, 2 to the minus L of xk. So this would be the length of the extended of the code word extension for the vector of length k that I'm summing over down here. So might help at this point to have a little example. So for instance, if I take a two-fold vector